Hello everyone, welcome back to our channel. So in today's video we are going to discuss an important concept called as variable acceleration from model number 4. So one question will be definitely asked on the final exam based on the variable acceleration. But before proceeding to the video, you should have some knowledge of differentiation and integration to solve the problems related to the variable acceleration. So we'll start with the understanding what is a velocity. Velocity is nothing but rate of change of displacement with respect to time. It is the rate at which a particular particle changes its position with respect to time. So in mathematically we can define the velocity as dx by dt, where x is the displacement. It can be represented by a symbol s. The velocity is represented by either v or u, where specifically v represent final velocity and u represent initial velocity. The velocity is dx by dt, means it is displacement divided by time. So the unit of velocity is meter per second. The second most important term here is acceleration. Acceleration can be defined as rate of change of velocity with respect to time, and mathematically velocity and acceleration has a relation, and it can be represented as a is equal to dv by dt, rate of change of velocity with respect to time. So the unit of acceleration is meter per second square, and it is represented by small letter a. Also there is one more formula for that, dv by dx into dx by dt. So here dx and dx will get cancelled, so we'll get the same term dv by dt. But now here dx by dt is nothing but the velocity as discussed in the previous slide. So the acceleration is equal to dv by dx into v. So this is a second formula for the acceleration. So acceleration is represented by dv by dt, or it is v into dv by dx. So you should remember these three formulas. First formula is velocity dx by dt, second formula is acceleration dv by dt, and last formula is acceleration v into dv by dx. After this, to calculate the variable acceleration numericals, we should have this formula list as discussed in the previous few slides. After that, we should remember this table. To get the velocity from the displacement, we should differentiate the displacement with respect to time. So we'll get dx by dt, that is nothing but velocity. To calculate the acceleration, we should differentiate the velocity with respect to time to get the value of acceleration. So for coming from displacement to the velocity to the acceleration, we do differentiation. And to go in the reverse flow, that is from acceleration to the velocity, we integrate the acceleration equation to get the velocity. When you integrate the velocity equation, we'll get the displacement. So to go in this flow downward, we should differentiate. To go in the reverse flow, we should integrate. So this table is very important. So for variable acceleration, we'll have only this set of formulas and equations. So where you should remember the formula for the velocity, two formulas for the acceleration, and this table. So to go down in the sequence, we differentiate. To go up in the sequence, we integrate. Now we'll see one numerical based on the variable acceleration. The position of the particle which moves along a straight line is defined by the relation x is equal to t cube minus 6t square minus 15t plus 40. Find the time at which the velocity is 0, the position and the distance traveled by the particle at that time, and the acceleration at that time. So all those values need to be calculated. So first we write down the equation. So you might get confused between this type of questions and the curvilinear motion questions. So here the value is given in only one dimension x, and y component is not given, but in curvilinear motion x and y components will be given. So don't get confused in that. The simple equation, if it is given, it is related to the variable acceleration motion. So x is equal to t cube minus 6t square minus 15t plus 40. To calculate first velocity, what we should do, we should differentiate the displacement with respect to time to get the velocity. So here x equation is given, so we'll find out the differentiation of y equation, that is dx by dt is equal to differentiation of t cube will be 3t square, then minus 6t square, so minus 6 into 2 into t, minus 15t. Differentiation of t is 1, so it is minus 15, and differentiation of 40 is equal to 0. So we'll get this equation. By simplifying this equation, we get dx by dt is equal to v is equal to 3t square minus 6 into 2, 12, minus 12t minus 15. So this is the equation of the velocity. So we'll call it as equation 1. The time at which the velocity is 0. For that, we can substitute here v is equal to 0. So this equation becomes 0 is equal to 3t square minus 12t minus 15. So we can solve this equation using the calculators. So we'll get the value of t is equal to 5 seconds here by doing the calculation. Then the next term will be second point, the position and the distance traveled by the particle at that time. So for that, we know t is equal to 5 seconds. So we can replace t is equal to t by 5 in this equation. So we get the value of x. So x5 is equal to, instead of t we'll write 5 here. So 5 cube minus 6 into 5 square minus 15 into 5 plus 40. So the value of displacement at velocity 0 will be minus 60 meter. Then the initial displacement of the particle at t is equal to 0. What is the initial displacement of the particle? It is x0 is equal to 0 cube minus 6 into 0 minus 15 into 0 plus 40. So 40 meter is the initial displacement. Now after calculating the initial displacement, what they have asked, distance traveled by the particle at t is equal to 5 seconds will be x5 minus initial displacement. So x5 value is minus 60 minus 40, so minus 100 meter. So distance is equal to 100 meter, minus only represent the direction of the travel. So distance traveled at velocity 0 will be 100 meter. Now to calculate acceleration at the same time, what we'll do, we'll use the velocity equation 3t square minus 12t minus 15. When we differentiate this equation with respect to t, we will get the value of acceleration. So we'll differentiate this equation. So dv by dt is equal to 3 into 2 into t minus 12 into 1 minus 0. So the equation of acceleration becomes 60 minus 12. This is the value of acceleration. When we put t is equal to 5, we'll get the value of acceleration. So 6 into 5 minus 12. 6 into 5 is 30. 30 minus 12 is equal to 18 meter per second square. In this way, we have calculated the value of distance traveled by the particle and the acceleration of the particle when the velocity becomes 0. So by following this method, we can easily solve these types of numerical. These are not much difficult, but you should have the basic knowledge of the differentiation and the integration. If you have the knowledge, then there is no different procedure for this question. Just you have to differentiate or integrate the given equation to find the corresponding values. I hope you find this video helpful. This video will definitely give you 4 to 6 marks related to the variable acceleration. So you can rewatch this video, you can share this video with your friends, and you can subscribe to our channel. Thank you very much.